Lesson 2.13, combinations. Our objective for this lesson is to be able to determine the number of combinations when selections are made from a single group of items, no item may be selected more than once, and order does not matter. So let's start by defining combination. A combination is a selection of items from a set in such a way that order does not matter. So for example, if I want to know how many groups of 3 students can I select from a class of 30 students, that's going to be a combination because the order of the students doesn't matter. All that matters is that we're selecting 3 students. So if order doesn't matter, then it's a combination. If order does matter, then it's a permutation. Next, let's talk about the formula that we're going to use to find combinations. So the formula is this: if we make R selections from a group of n items, the number of combinations is going to be given by this formula. So we say NCR, so this is the number of combinations of R selections from a group of n items, is equal to n factorial divided by n minus r factorial times r factorial. Now, you may notice that this is very similar to the permutations formula that we had in the last video. In fact, if we covered up this r factorial, this is the permutations formula, n factorial divided by n minus r factorial. This, the combinations formula includes this extra r factorial in the denominator. So I want to explain where this extra r factorial comes from by doing the first example in this lesson and comparing it to the first example in the previous lesson on permutations. So in this example, we are told that there's a math club with 25 members, and they want to select a team of 4 to represent their club in the state championship. This is a combination because the order of the team doesn't matter. It doesn't matter how you arrange the 4 members of the team. They're still the same team. This differs from the previous example because in that example, they were electing a president, vice president, secretary, and treasurer. So taking the same group and giving them different positions would result in a different leadership team. But with the team that they're sending to the state championship, the order doesn't matter, so it's a combination. And let's first talk about the permutations that we got from the previous lesson. So we said that there was a president and a vice president and a secretary and a treasurer. And when we go to select the president, we've got all 25 members of the group to select from. But once we've selected a president, we only have 24 left to select the vice president, then 23 for the secretary and 22 for the treasurer. And we multiply all those together and we get 303,600 different permutations, different leadership teams that we could create. But now let's say that we elected Amy as the president, and we elected Bob as the vice president. We elected Charles as the secretary and Debbie as the treasurer. Now, these would be a different leadership team if we made, say, Debbie the president, and Amy the vice president, Bob the secretary, Charles the treasurer, something like that. That would be a different leadership team, but it would all still be the same group. If order doesn't matter, that's the same group. So we've overcounted the number of combinations that we need. And how much did we overcount this? Well, how many different ways could we arrange these 4 people into different permutations? Well, if we've got the 4 of them, and if we're putting these 4 in order, we could put any one of the 4 first, and then we'd be left with 3 for the second, and 2 for the third, and 1 for the fourth. So there's 4 factorial 4 times 3 times 2 times 1 ways that we can rearrange Amy, Bob, Charles, and Debbie in different orders. But again, they're all the same team. So we've overcounted the number of combinations by a factor of 4 factorial. So we need to now divide this 303,600 by 4 factorial. And that's what we're doing in our formula here. You can see we've got our permutations formula, and then we're dividing by an extra r factorial. So let's go back to this example now. Forget about the previous example and just figure out how many combinations we have. So we've got, it's a combination, and we're selecting 4 team members out of 25 members of the math club. And this is going to be equal to, our n is 25, so this is 25 factorial, divided by 25 minus 4 factorial times 4 factorial. And so if we plug this into our calculator, 25 factorial, now, by the way, notice that this is 25 factorial divided by 21 factorial and 4 times 4 factorial. So these two numbers here are always going to add up to this number here. 21 plus 4 is equal to 25. And that should make sense because n minus r plus r is going to be n. So as you're doing these, make sure that these two numbers in your when you're calculating the number of combinations, these two numbers should add up to this number here. So 25 factorial divided by 21 factorial times 4 factorial is going to be 12,650, which is the same as our permutations, 303,600 divided by 4 factorial, which is 24. So we end up with 12,650. That's how many different teams of 4 that we can send to the state championship from our 25-member math club. Our second example asks, if jelly beans come in 40 flavors, how many different 3-flavor combinations are possible? So here, this is going to be a combination because the order doesn't matter. We're just going to select 3 different jelly beans and eat them all at once to get that flavor combination. And so we're choosing, we're selecting 3 different flavors out of a possible 40 flavors. And so our n is going to be 40, our r is 3. So this is going to be 40 factorial divided by 40 minus 3 is 37 factorial times 3 factorial. And then we can plug this into the calculator. Now, be careful when you're plugging this into a calculator, because if you put in 40 factorial divided by 37 factorial times 3 factorial, that's going to give you the wrong answer, because what's happening here is we're taking 40 factorial divided by 37 factorial, that's our permutation, and we're dividing by another 3 factorial. So when you have this multiplication happening in the denominator, you either have to use some parentheses or you have to enter this in some different order. So the way that I would enter this into a calculator is I would put 40 factorial divided by 37 factorial divided by 3 factorial. So 40 factorial divided by 37 factorial, hit enter, and then divide by 3 factorial. And that will give you our answer, which in this case is 9,880 different 3-flavor combinations of jelly beans.